lesson is titled Rational Exponents. Another way to write a radical expression is to use a rational exponent. Here's an example. The square root of 25 is exactly the same as 25 to the 1/2 power. The cube root of 27 is exactly the same as 27 to the 1/3 power. And the fourth root of 16 is exactly the same as 16 to the 1/4 power. This pattern continues for any nth root of x. That's exactly the same as x to the 1 over n, or 1/nth power. In this example, we're asked to simplify the expression, 125 to the 1/3 power. If we understand that's just the cube root of 125, then we should know that's 5. 5 to the 1/2 times 5 to the 1/2 is exactly the same as root 5 times root 5, or 5. 10 to the 1/3 times 100 to the 1/3 is the same as the cube root of 10 times the cube root of 100, which is the cube root of 1,000, which is 10. 10 times 10 times 10 is 1,000. You try. Simplify 16 to the 1/4 power. If you need more time, press pause. This would be the same as 2. It's the fourth root of 16. Remember, the way to take a fourth root on a number is to do the square root twice. The square root of 16 is 4. The square root of 4 is 2. How about 2 to the 1/2 times 2 to the 1/2? If you need more time, press pause. That's just root 2 times root 2, which is 2. How about 2 to the 1/2 times 8 to the 1/2? This one's a little more difficult. You might want to press pause and play with it. Well, that's the same as root 2 times root 8. But remember, root 8 simplifies, or we could just go ahead and say root 16. And root 16 is 4. Root 8 simplifies to 2 root 2. The root 2 times root 2 is another 2, and 2 times 2 is 4 is another way to do the problem. If the nth root of a is a real number and m is an integer, then the following is true. A to the 1 over n is always the nth root of a. A to the m over n is equal to the nth root of a to the m, or the nth root of a all to the m. The key here is to realize that when we're looking at the bottom number in this fraction, that's always the root index. The top number in this fraction is always the power on the a or the whole expression. You get to pick which way you want to use that. If m divided by n is negative, then a can never be 0. Actually, because you'd be taking 0 to a 1 over kind of a thing. We can never do that. Write the exponential expression in radical form. This is an example. So if we're going to write this in radical form, we need to realize that that's a fifth root and then cubed. So one way to write it is the fifth root of x cubed with the 3 inside. Another way would be to use parentheses and put the 3 outside. How about y to the negative 2.5? Well, I don't know what to do with decimals, but I do know what to do with fractions. So I'm going to change the decimal to a fraction. That's y to the negative 5 halves, which is 1 over y to the positive 5 halves. Remember, this negative sign, all it does is take the y across the fraction bar. After it does that, it's done its job, and we're positive now on the 5 halves. We're still not as simple as we can get, because we need to get to radical form. So we need to realize that the 2 is a square root, indicates a square root, and the 5 is a power on the y, or the whole expression with parentheses. That one's a little tricky. It involves the negative and the exponential expression there. The radical exponent. I should say rational exponent. Write the radical expression in exponential form. So now we're going the other direction. We've got a square root of a to the 3rd. So that would be a to the what power? It'd be a to the 3 halves power. Remember, the index here is 2, so that's going to be the bottom of my fraction. The power is always the top number. How about the fifth root of b squared? Well, that would be b to the 2/5. The index is always the bottom number in the fraction. The power is always the top number. Properties of rational exponents. we have quite a few properties that we need to understand here. We're going to let m and n represent rational numbers, in other words, fractions, and we're going to assume that no denominator equals 0. Property, a to the m times a to the n equals a to the m plus n. Now this doesn't work for just fractions because 5 is a rational number. We can write it as 5 over 1. 2 is a rational number. We can write it as 2 over 1. So this would be a to the 5 plus 2 or a to the 7. What does that look like in numbers? Here's an example. A to the 1/3 times a to the 2/3 is equal to the 8 to the 1/3 plus 2/3 or 8 to the 1, which we should just write as 8. So when you're multiplying like bases, the same is true whether these are fractions or whole numbers. You just add the exponents and you keep your base. When you raise a power to a power, that's the only time you get to multiply powers. So a to the m raised to the n is a to the m times n. Here's an example with numbers. 5 to the 1/2 to the 4th is the same as 5 to the 1/2 times 4th, or 5 squared, which we should write as 25. When we have parentheses in an exponent, the exponent works on everything inside the parentheses. So we could write that as a to the m times b to the m. Here's an example with numbers. 4 times 5 to the 1/2 is the same as 4 to the 1/2 times 5 to the 1/2, or 2 times 5 to the 1/2. It's kind of an ugly way to write it, but 5 to the 1/2 doesn't simplify like these other numbers did. 4 to the 1/2 is just root 4. That's where the 2 came from. A to the negative m is the same as 1 over a to the positive m. Remember, this negative sign, all it does is move the a across the fraction bar. Once it's done that, it's done its job, and it becomes positive there. An example, 9 to the negative 1/2 is the same as 1 over 9 to the 1/2. Remember, this is just root 9 or 3, so the whole thing just becomes 1/3. A to the m over n, this is a lot like the ones up here where we were multiplying like bases. Now we're dividing like bases. The rule on multiply like bases was add the exponents. The rule on dividing like bases is subtract the exponents. Here's an example. Pi to the 3/2 over pi to the 1/2 is the same as pi to the 3/2 minus 1/2, or pi to the 1, or we should just write pi. One more fits here. Just like the parentheses here, the m works on everything in the multiplication. The m works on everything in the division inside the parentheses. So we could write a to the m over b to the m. Here's an example. 5 to the 1/3 over 5 over 27 all to the 1/3 is the same as 5 to the 1/3 over 27 to the 1/3. 5 to the 1/3 doesn't simplify, but 27 to the 1/3 is just the cube root of 27, which is 3. You might want to copy these down in your notes and study them over time, especially this side. These are the properties of exponents, things that we need to understand about exponents. Use those properties to simplify this. The font in this didn't come out so great, but this is negative 32 to the 3/5. That's the same as the 5th root of negative 32 all cubed, if I choose to write it that way. The 5th root of negative 32 is just negative 2, and negative 2 cubed is negative 8. So that whole thing just boils down to negative 8. How about 4 to the negative 3.5? Well, again, I don't know what to do with decimals, but I do know what to do with fractions. That's the same as 4 to the negative 7/2. I like to deal with the negative as quick as I can. That's going to take the 4 across the fraction bar, brings the exponent with it, but keeps it positive when it gets here. So it looks like I'm looking at a square root of 4, which is 2, and I'm going to raise that to the 7th power, which is 1/28. So this is the same as 1 over 128. Let's look at some U-try problems here. Go ahead and pause the video as we look at these and try them. So go ahead. What's 27 to the 2/3? You should get 9. The cube root of 27 is 3, and 3 squared is 9. Try another one of those. What's 8 to the 2/3? You should get 4. The cube root of 8 is 2, and 2 squared is 4. One more of these. What's 8 to the 4/3? You should get 16. The cube root of 8 is 2, and 2 to the 4th is 16. Let's look at the next kind. Write the exponential expression 9x to the 9/10 in radical form. So we're switching from exponential form, which is what we're looking at here, to radical form. Remember, radical form, we need to see that radical symbol. Okay? Exponential form, we're going to see the exponents. So give that a shot. We should have 9 times the 10th root of x to the 9. The 9, nothing happens to the 9 because the 9/10 isn't working on that. It's just working on the x. So leave the 9 alone, write the x inside of a 10th root, and raise it to the 9th power, and you're good to go. Let's give you another one of those. How about 5x to the 5 halves? Pause if you need a little more time here. That is the same as 5 times the square root of x to the 5th. Remember, this 2 here is the index, so it tells me the kind of root. It's a square root, and the 5 is the power that we're still going to have on the x, or the whole root. Sometimes it's easier just to write it on the x a lot of the times. Let's go to the last kind here. Ooh, this one's a little tougher. We're dealing with negatives. We're dealing with parentheses. We got a lot going on here. Go ahead and try that. And then you might want to pause, take your time, give this a good try, and then when you're ready to check your answer with mine, press play. All right, this one's complex enough that we just might want to work it out here instead of trying to do it verbally. I'm going to break this apart. Remember, we've got the parentheses here, so the power works on everything. So I have 27 to the negative 2/3, and times I have a to the negative 9th to the negative 2/3. There's a lot going on here. So let's see. This negative says I need to flip that 27 over. I'm dealing with a cube root here. So I've got the cube root of 27. And this whole thing is going to get squared. That's what the 2 on the top is doing. Times. This is a chance here where I get to multiply powers because I have a power raised to a power. So let's go ahead and multiply that and let the negatives take care of themselves there with multiplication. That would be a to the, let's see, negative times negative is a positive. 9 divided by 3 is 3, and 3 times 2 is 6. That's going to be a to the 6th when that gets done. 9 times 2/3 is 6. Let's evaluate this. The cube root of 27 is 3, and 3 squared is 9. So that's the same as 1/9 times a to the 6th, which we would probably write as a to the 6 over 9 for a final answer. Check that with the software here, make sure they got the same thing. They got a to the 6th over 9. Study that if you need. Pause if you need to. Otherwise, I'm going to give you another one to try here. I guess that's not really, it's not really doing much here. There we go. Give that one a try. Go ahead and press pause and give that one a try. All right, did you get it? I'll just bring up the answer. She got 8 to the 12th over 16. If you didn't get it, this is what they did. We have 8 to the negative 4/3. And we have a to the negative 9 to the negative 4/3. That negative here is going to flip that over, so it's 1 over 8 to the 4/3 times negative is positive. 9 times 4/3, well, 9 divided by 3 is 3. 3 times 4 is 12, so that's the a to the 12th we're going to see. Let's see where the 16 comes from. The cube root of 8 is 2, and 2 to the 4th is 16, so there's our 16 on the bottom. Remember, the cube root of 8 is 2, 2 to the 4th is 16, and then our a to the 12th would be on the top after we multiplied it together. So hopefully you got that. Let's go ahead and kick out of here now. And we're back into the PowerPoint. That's our learning target. I'll see you in class.